Okay, now what we have seen is that we are talking about point mass, that is m1. These are point masses. Now what about a regular shaped body? What about a regular shaped body or an irregular shaped body? When we want to find the center of mass for this particular shapes, then what should be our approach? Now the important thing is that we should know the basic concepts. Say suppose you are drawing a coordinate. You are drawing a coordinate. Now each of the body particles, that is each of the particles that is present in the body, can be considered as very small mass. Say suppose for this body, if I consider this small circle, so this can be taken to be delta m, where delta m is a small part, where delta m is a small part. Okay, so we can use the concepts that we have learned and we can apply this for a rigid big regular body. All we have to do is we have to take small elements, that is small particles from the rigid body, and we have to take out the summation and with respect to its distance divided by total mass, and we will have our center of mass. So let's say suppose we have assumed the body to consist of del m particles and it ranges from 1 to till n, that is del m I, and its coordinates, say suppose for del m I have taken the coordinates to be xi, yi and zi. So this is the coordinate that I have taken. Therefore the center of mass, as according to the formula that we know, is actually equal to del mi into x1, that is the position vector for del m, and summation of del mi. Similarly, y can be written as summation del mi yi summation of del mi. So these are the things that you can consider. Similarly, z can also be written in such a way. Now as we make n bigger, that is n is the number of particles, that is as we make n bigger, if we increase n, that is the number of particles in this whole body, then the size del m decreases. So this is a statement where you might get confused. So look over here, if for this particular object I have taken 4 particles, for this whole object I have taken 4 particles. Now if I want to increase the number of particles, say suppose for this particular object, now I have taken say around 9 particles, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now as you can see, the size of the particle gets on decreasing, it keeps on decreasing. So this is what the statement actually means. If we increase n, that is the number of particles, our size del m decreases, that is del m becomes smaller and smaller. So our expression actually becomes something like this: summation of del mi xi. Now del m, the summation of del m can also be written as integration of dm. Del m can be also written as integration of dm, which is equal to m. Summation of del m, that is the sum of all the particles, can also be written as integration of dm, where dm becomes very small, which is equal to the whole mass m. So the integration becomes m. So we can modify this formula. We can modify this formula in such a way that is summation of del m xi can be converted into x dm, can be converted into x dm. This whole summation can be expressed as x. This whole summation can be expressed as integration of x dm. Similarly for y. Similarly, if I talk about y, then this becomes summation of y dm. I'm talking about y, and z becomes summation of z dm. So this is the new formula that we can convert into, and the basic concept of this particular formula, you maybe in the book it's given straight away, integration of z dm, but the basic concepts comes from here. Basic concepts comes from here, such that del m when it decreases, integration of del m is actually equal to this dm, which is equal to m. So the formula or the basic concepts come from this particular explanation. If we increase n, del m decreases, and del m converts into dm, that is for a very small m, that is a very small m. Now if we integrate this small m, we will have our whole system. Now we know for a regular body, if I take a small part and I give the condition, and if I give the necessary integrating condition, say from 0 to say some x, then I'll have the whole of my regular body, and in this way center of mass of a regular body can be calculated. So from the above modified formula, now we come to the conclusion that for x-axis, for y and for z, my center of mass, this is the coordinate of the center of mass, x, y and z. Now this is the length, that is, for this we have the formula 1 by m integration of x dm. For this 1 by m integration of y dm, and for this 1 by m integration of z dm. Now we arrived at this formula from here, del m into xi by summation of mi, or you can say summation of del mi. Now this formula, this particular expression as we have derived is actually equal to x dm. This particular part is actually equal to x dm, and this particular part is actually equal to m. So the modified formula is 1 by m whole integration x dm. So this is what we have written over here. So in this way you can understand. So now this is for x, this is for y, and this is for z. Now if I want to write the whole of the vector node, whole r, that is the whole center of mass, if I want to express, or if I want to combine x, y and z, so I'll take r over here. Therefore r is actually equal to 1 by m, this is 1 by m into r dm, where r stands for x, y and z. R stands for x coordinate, for y coordinate and for z coordinate. So this is what is given for a center of mass for a regular body. Now there is an interesting concept that you can apply. Say suppose you have chosen your coordinate axis, that is the origin to be at the center of mass. You have chosen the origin to be at the center of mass. So what will happen then? If I've taken the origin to be at the center of mass, that is at r equals to 0, 0, 0, so we know that r is actually equal to 0. We know that r is actually equal to 0, and therefore this particular formula converts into, as I've mentioned in my previous videos, that we can choose the coordinate axis to our own convenience. So if I've chosen the coordinate axis in a position where the center of mass lies, therefore the r becomes 0. So 1 by m r dm equals to 0. This implies m goes over here. Summation of r dm equals to 0, because m gets multiplied with 0, the result is 0. So summation of r dm is equal to 0. And this in turn, we can understand that if r dm is equal to 0, then x dm is also equal to 0, y dm is also equal to 0, and z dm is also equal to 0. So this in turn we can write as x dm equals to 0, y dm equals to 0, and z dm equals to 0. This is how we can understand, or this is how we can apply this particular formula.